Okay, everybody. So we are live. So today's lesson had to do with inverses, which we've talked about in Algebra 2. So that helps a lot. So we're going to be graphing inverses and finding their functions, okay? So the symbol is this symbol for an inverse. And what we do is we take any point, x, y, and we switch it to yx. So we switch every x value for every y value, okay? So does every function have an inverse? No. So if the function does not pass the horizontal line test, it does not have an inverse. So we showed two examples. This one here has an inverse. I drew it in blue. This one here does not, because if you take a look and switch it, x and y, you get a graph here that does not, that's not a function. The inverse is not a function. We'll say this one does not, this graph does not have an inverse. And we said one of the easy ways still is called a horizontal line test. So if I draw a horizontal line test, if it fails horizontal line test, then if the original fails a horizontal line test, then the inverse will fail a vertical line test. So therefore, it does not have an inverse. So we talk about this thing called one-to-one correspondence, where every x has only one y, and every y has only one x, okay? All right, then, if that's the case, we looked at these examples. These are just points. These are points. I've got a point 5, 7. And if I want the inverse of 7, well, that means that the 7 becomes the x. We get 5. They just switch them around. This one says take the inverse of 7. Well, the inverse of 7 is 5. And then take f of 5, and that's 7. Okay, so we just went right back where we were. Okay, example 2. I graphed the first line. The function here is in purple. I graphed the inverse. Here it is. That's g of x. And then to prove their inverses, what we have to do is this. You have to plug the one into the other and plug the original into the other. They both should equal each other and they both should equal x. So what we did is we took f of f inverse, so this is my inverse, and we plugged this one into f of x. We plugged it 2x plus 1 into f of x. There it is. I simplified, the ones cancel, divide by 2 and I get x. Then I took the original and put it into the inverse, okay? So I put my x minus 1 over 2 in for 2x plus 1. Cancel the 2's, the 1's cancel, I get x. So sure enough, it follows. They must be inverse of each other, and that's how I proved it, okay? All right, turn the page. Number 4. So when I grabbed the parabola, in fact, I erased it. The whole parabola here, 4 minus x squared, is this parabola, but we can't have it. It won't have an inverse. Okay, so in order to make sure it has an inverse, we change the domain. So I said, okay, let's just make x greater than or equal to 0 only, so it gets rid of the negative half. So then it has an inverse. Okay, yes. Now we can say yes, it has an inverse. Before we'd say no, it does not. So then I wanted to graph the inverse. I took all of the points off the parabola, 0, 4, 1, 3, 2, 0, 3, negative 5, and I switched the points because I wanted the inverse. 4, 0, 0, 2, 3, 1, and negative 5, 3, and I graphed those points in purple, and I graphed it. Now that sure looks like a square root graph to me. So then what I did is I ended up finding what the inverse graph was. So instead, I switched both. So I took my f of x equals 4 minus x squared, but changed it to y because fx is equal to y. And then I switched the variables because I'm looking for the inverse. I switched the variables. And after I switch the variables, then what I want to do, it's yellow, okay, is I solved it. So I went from minus 4, minus 4. I didn't like the negative here, so I multiplied by negative 1. I like it rewritten in the other form, and then I took the square root. Now, normally the square root of y squared would be a plus or minus, but I don't need the minus because I already established that I want the positive part of the graph. So the inverse is just simply f inverse of x is equal to 4 minus x, square root of 4 minus x. Okay, that's all I had. If you have any specific questions, come see me. The homework is right here from page 149.